they've seen it before, but some of you don't remember what happened on Friday, so, so, an oblique triangle is a triangle with not a right angle in it, right? So right triangles are really special. Oblique. Obtuse. It just means not a right triangle. So for me, when I do these, I always call them A, B, and C, unless they give me another angle. And I call the angles capital letters, and the side across from them lowercase letters. Sometimes your book might use Greek letters instead of capital letters. I'm not going to focus a ton on what you have to know right now. We'll kind of figure that out. But I only mention this because it should bring back some memories of geometry class. If I talk about two angles and any side, that could be like angle, side, side, side. Two sides at an opposite angle, side, angle. Don't write angle, side. Two sides and their included angle, side, angle. Careful there. Maybe you remember in geometry that angle, side was a problem for us because it doesn't prove that two triangles are congruent. Angle, side is going to be a problem for us as well as we do all sines. Not that we can't do it, but that sometimes it leads to no triangle or sometimes it leads to two triangles. And so we're going to talk about that today as well. But the law of sines just says you can write the sides of a triangle as ratios with the sines of their angles and into a proportion. Maybe you have a vague memory of geometry class. That's the point. So you can say the law of sines, I can see what's on Tuesday. So we can say that side A over the sine of the angle equals B over the sine of angle B equals C over the sine of angle C. And if you remember about proportions, it doesn't matter which way you write it, or they're reciprocal. So if you wanted, you could say that's the same as the sine of A equals the sine of B over B equals the sine of C over C. And you'll get the same answer as long as the angles are across from the other angles and the sides are across from the other sides. For me, whatever I'm solving for, if I'm solving for an angle, I put the angle on the top. If I'm solving for the side, I put the side on top. Because let's see. A, B, C. It doesn't matter how you draw your picture as long as you label it accordingly with the side and the angle. So angle A, I'm going to label it as 102.4 degrees. Angle C is 16.7 degrees. And side A is across from angle A is 21.6. Remember that solve a triangle means find everything that's missing. In a triangle, there are always going to be three things missing. They're going to always give you three things, and you're going to have to find them. In this question, what's the easiest thing to find first? If they give you two angles, you should be able to find that third angle, no trig needed, right? How am I going to find angle B? Subtract from 180. And notice that we're using degrees, not radians. I got 60.9 degrees. So hard. Now to find the sides, you have to do all sides. Like there's no other option of how to find the sides here. So it doesn't matter. You could find side B first or side C first. You got to find them both. So I'm just going to go alphabetical here, and I'm going to find side B, and I'm just going to put up the proportion that B over the sine of angle B, which is 60.9, And I have to use the one that I know the angle and the side. So I can't use C, because I don't know what side C is. So I have to use A and angle A. So that's going to be 21.6 over the sine of 102.4. Really great if you show me that, because I can, if you type something wrong in your calculator and you don't show me that you set it up right, I can't give you partial credit for that. So what would you do to solve this? I would do too. I used to always just cross multiply. Did you think about cross multiply? Did I tell you the story already? I taught law science like 4 times already because of my math class, so I've told this story a lot. But I used to always do the cross multiply because I saw proportion, and it's not wrong to cross multiply. But in from Thailand, a foreign exchange student I had years ago, I did the cross multiplying on law science, and he said, "Why would you do that? Why wouldn't you just multiply by the sine of 60.9, and then like you solved for b already? Whereas if you cross multiply, then you still have to divide over." You see what I'm saying? And I was like, how am I an idiot? Like, how have I never thought of that before in my whole life? So I just like to share and acknowledge with you that I always do this now. I never cross multiply. That's why I always put what I'm solving for on top here, so that way I can just multiply it over. And so if you want to cross multiply, I promise you get the same answer. I did it for years. Now I just type this all in my calculator. I just type in 21.6 divided by sine of 102.4 times sine of 60.9, and then I don't have to do 2 steps. Be careful on your calculators because it starts a parenthesis after sine, and you have to close that parenthesis or it'll keep the sine falling out of it. So that's not when it starts happening. Okay. And then to solve side C, do you agree we just have to do it again, but now with C? What's really great about your calculators is, on my calculators at least, you can arrow up and get back that same line, and all we're doing to solve side C is changing this bottom now, right? Like I would write this as C over sine of 16.7, and I'm going to keep this side the same. I'm going to keep that as 21.6 over sine of 102.4. So what I do is I try to save myself from punching in a million things on my calculator, is I just arrow up back to that thing I just typed in, and I just scroll over to where I typed in 60.9, and I just change that to 16.7, and then that would be the exact right thing. You see what I'm saying on that? Have any clue what I'm saying? Hello? Alright, just get over. I got 6.4. Did you get 6.4? Any other question on how I got those? Really nice if you write messy, or if you're like me and you have stuff everywhere. It'd be so nice for your teacher if you go back and like circle your 3 answers so she's not circling. Alright, the ambiguous case, the case that you're not really sure what's going to happen, happens when we have side-side angle. If they give us 2 sides and not the angle in between, the reason that we couldn't prove that triangles were congruent in geometry with that is because sometimes it makes no triangle. And so when this happens, 3 things can happen. One is it doesn't even make a triangle because you couldn't connect the sides to make like the angle. It just doesn't work. Another option is it works out just like the last one. We get 1 triangle, it works out awesome. The third option is that it could make 2 triangles. One being like an obtuse triangle and one being a obtuse triangle. I'm not going to attempt to solve it, but in your book, they explain this and they kind of work it out here on page 480. They kind of show the options of like it doesn't make any triangle, it makes a perfect triangle, or this bottom case where you can solve it and you can get 2 triangles. There's another, like there you go through those examples. Page 480, if you're looking at that. There's a ton of stuff online, I should and look at it. What I want to do is do an example with you, or maybe a couple, we'll see how much we get to show you what does that look like when we do this. So we're going to start it out the same way we started the last one. It doesn't matter whether your triangle looks accurate or not, it's just to help you as a visual, so don't worry about it. Okay? But as long as I label angle A and the side across from it correctly, and then side B is this. So what you need to be aware of is when do they give me angle side side, and make sure you know, oh, well, maybe there's no triangle, or maybe there's going to be two triangles. And this is definitely angle side side because the angle is not. So a little bit harder of you have to start a certain place. What do we have to start with solving on this one? Can I solve for this side right now? Because it's not a right triangle, so I can't use the Pythagorean theorem, right? I can't solve for angle C either, because if I don't know the side or the angle, think about it. You're going to have C over sine of C. I don't know either one of those. So you have to start with the side that you know and the angle that you don't know. So you have to start by looking for angle B. Right? There's no other option. So we're going to write this as sine of B over B, which is called weight. And then they're always going to give you an angle and the side across from it. Otherwise, you can't do all sides. So, like if they gave you angle, 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 that's not enough to do. You can't do all sides. That's why we have that. And so I'm going to set that equal to the sine of 58 over 11.4. And just like the last one, I'm going to multiply by 12.8 to move that over. But notice now we're solving for the angle, not the side. So this is not what B equals, it's what the sine of B equals. So when you type that in, you should kind of get an answer that you think's wrong at first, because you think it should be. When I type that in, I get 0.952194354. You get that? So this is not what angle B equals, and hopefully you won't ever give me that as your answer, because that's telling me, if you gave me that's the answer, you're telling me that angle B doesn't even measure 1 degree, right? That doesn't make sense. But it's what sine of B equals. So what do we do when we want to solve for B and we have sine of B there? We do inverse sine, right? So to get rid of sine, we're going to do inverse sine to both sides. We don't usually show this side, but we do that because that makes the sine go away. So you're going to do inverse sine. Maybe you could think right now what's going to happen if there was no triangle. Your calculator is going to tell you there's no triangle, because what's the biggest sine can ever be? 1, and the smallest it can ever be is -1. So guess what happens? If this number right here is bigger than 1, and you try to take the inverse sine of it, it's going to say domain error on your calculator. And that means that those 3 things don't make a triangle. So if you ever get domain error, probably that means there's no triangle. I did this and I got 72.2 degrees. Did you get 72.2 degrees? So here's where you have to know that it's the ambiguous case. There could be another angle, because when we solve these equations before, not in triangles, but just solving them, remember that there's 2 answers every time, right? Sine's positive in 2 quadrants, it's negative in 2 quadrants. So this 72.2, that's the one in quadrant 1. The other quadrant is sine always positive. Quadrant 2, which means this is how sometimes you get 2 triangles. You have to figure out what is this other angle over here. And it's always going to have that same reference angle, right? And law of sine, it's always going to be sine. How am I going to get there? How am I going to measure from 0 to here and figure out what that is? It's just going to be 180 minus 72.2, right? Because I just want to measure from 0 all the way to here. So that second angle is always just going to be 180 minus whatever the first one is. And there's always going to be a second angle. But what you have to determine is, does it make a triangle? So there's always going to be two answers when you do inverse sine. But the question is, some angles don't make a triangle. So what you have to determine is look back up there and say, if I have 58 degrees and I have 107 degrees, do I have some degrees left over for a third angle? Yeah, because 58 plus 107 is not 180 yet. Do you agree with me on that? What if my second angle was 140? If this was 140 and this was 58, could you make a triangle out of that? No. So that's how you would say, well, that doesn't exist. So you have to kind of look at it every time and determine it. This is an example where there's going to be two triangles. There's some questions on your homework that just say, is there one, two, or no triangle? And if you got to this point and you knew there were two, you could stop. Other questions on your homework are just like this that say, actually solve it, which means we found there's two of them. We got to solve it for both of them. So now, for both of these, we have to go back and say, could I find the angle C that goes with this triangle? And could I find the angle C that goes with this triangle? And I'm just going to subtract from 180. I'm going to take 180 minus 58 minus 72.2, and I'm going to get 49.8 degrees. So this triangle would be a little acute triangle. But then on this one, angle C is going to be a lot smaller because I have to subtract 58 minus 107.8. And this one, angle C, is only 14.2 degrees. And then what else do I still have to find? You have to find side C for both of these, which is just doing law of sines again. You're just going to set up your proportion with 49.8 degrees. You're going to set it up with 14.2 degrees, and that same information up there, and you're going to find, we're running out of time, so I'm going to stop maybe. You're going to find two more answers there. Okay? That's the longest one. When there's no triangle, it's much shorter because you get that that's bigger than one when you get to stop. So we're going to stop from there, and I'm going to have you try homework, and then we'll start tomorrow back with going over an example of one and none or finishing these problems here. But make sure you read the directions tonight, but sometimes you don't read directions. But like 15 and 18, it just says, is there 0, 1, or 2 triangles? So hopefully you read that and you don't waste time actually solving it all out if there's two. Okay. And 27, 30, 33, and 36 say either you cannot solve it, no triangles are formed, or you actually have to solve it. So on some of those you might say it doesn't even make a triangle, I can't do that. Okay? Go ahead.
Questions. The office, please. I need Haley down to 8th grader. I need Madison Aker, Savannah Junkin, Avery Fields. The office, please. Avery Fields, Madison Aker, Savannah Junkin, and Haley down to 8th grader to the office.